everyone. Please, return your scantrons for quiz 4. And before I start the session, while you're doing that, I just make an announcement that you should be able to see student evaluations right now. And I ask you, all of you, to fill them out. And I will use your feedback for the course for the next semester. So if you saw something that you liked, for instance, if you liked having the textbook, if you liked having extra assignments, if you like things, just like say, so I can use your feedback. Also, if you didn't like something, you didn't like extra assignments, or you didn't like certain aspects of the course or the way I teach or anything, just like give me feedback, and I really appreciate it. And then when you have like the answers, kind of like strongly agree, strongly disagree, just pay attention. Sometimes you mean to choose like a strongly disagree, but by mistake you do, you choose strongly agree. So just be careful of that, because as I said, I really value your feedback, and it doesn't affect your grade. If you give me like bad review or like good review, I will see them after the semester is over, and it's anonymous. So I really ask you to fill them out. I know it just can be boring, or just like you have other things to do, but the deadline, is like, I think December 14th, if I'm not mistaken. So anytime that you have time, I gently, ask you, I just like really appreciate if you do that. And then when you have like 2 questions for like the course in general, but then it would be like evaluation based on the instructor. So just pay attention to that too, because you're going to evaluate me and Professor Estelle. So I really want you guys, to know which instructor you're evaluating, so I can, use your feedback, as I said. So any question about the student evaluations? Good? Okay, so I wrote your exam for last night. I started writing that before, but I finished that last night. So I thought, first of all, I gave your tutor the questions, and I asked her, and also the problem statements, the homework problems that I gave you previously, I asked her to solve those for you, the homework problems. And your exam is really similar to your homework problems. So if you did those, and then you know them, you understand those, you should be in really good shape for your exam. And to help you further, I also, before coming to the class, I went to the questions that I wrote, and I make notes of them, and I'm going to kind of review the chapter quickly and then solve the quiz for you. And before I forget, I just give you, try to solve all the quiz problems and tell you how to solve them, explain them. But I'm going to post the solutions to quiz 4 today, So even if I don't go through all the problems or not solve them till the end, you will be having all the solution procedures. So don't worry about that. And just focus on like what I'm saying, and then ask me any questions that you have. Is that clear? And I scheduled all the makeup exams this week because the materials in the previous chapters were really important for your exam 4. So I wanted you all to review those so you do well in your exam 4. But I had some students emailing me that there were some confusion about exams, or like they couldn't take makeup exams. So if you still feel the need and you want to take the makeup exams, just email me and I try to accommodate all of you. Any question about that? But as I said, I really wanted you to study chapters 1 to 6, because if you don't know those chapters, I think there is no way that you know chapter 7, 8, 9. Yes?
So will exam 4 be on chapter 7 and 9?
Yes.
Okay.
Yes. And then I'll teach you chapter 10 next week, and that would be on your final exam too. So your final exam is from chapter 1 to 10. And again, it's listed in professor schedule. It's like your final exam is like 10:14 a.m. till 12:14 a.m. No, sorry, 12:14 p.m. It doesn't take like that much of time, but 2 hours. So, and then you can see the location is the same, but the date is also not. This Friday is exam 4, not the next Friday, the Friday afterwards, but the exact, time, location, everything is in professor schedule. Any more questions? Are we clear about everything? Okay. So, first of all, let me go through these slides. And as I said, if you know the answer to all these questions and you did all the homework, and again, I'm going to post these like I did for the previous session that I posted a PowerPoint. I'm going to post these as well, so you don't have to worry about writing them. Just, pay attention, and we can all do really well on exam 4. If you know these materials that I'm telling you today, you know how to do your quiz 4, and you know how to do the homework problems, I think there is no way that you cannot get an A in exam 4, honestly, unless you don't know these things. Anyway, so what is a combustion reaction? Can anyone tell me what is a combustion reaction? Yes? Say it.
It has to do with like a gas and it like fire.
So one of your reactants reacts with oxygen and produce oxygen containing a species. So anything that you see, like CH4 plus O2 gives CO2 plus H2O. C plus O2 gives CO2. H2 plus O2 gives H2O. So if you have oxygen on the left side of the equation, so let me also write this. So you see one reactant plus O2 gives oxygen containing species, right? And then if you have, like in most cases, you see CO2 plus H2O. Usually you see water, but also C plus O2 gives CO2 is a combustion reaction. So as long as you see oxygen here and oxygen containing a species such as H2O, CO2, on right side you have combustion reaction. Any question about that? So I gave you a question, say which one of the following is not a combustion reaction? We should be able to identify that. If you see O2 here and oxygen containing a species on the right, is a combustion reaction. What is a gas evolution reaction? Can anyone tell me what was that? Exactly, you see a gas being produced. And I asked you, you had a table in your book that listed all the compounds that they go through gas evolution reaction, and we listed the gases. Any questions? Guys, I need all of your attentions. I have lots of materials to go through, and as much as I can go through these slides, more questions of exams you have. So please cooperate with me, have all your attention. And if you don't want to listen to the lecture, you can just go out and then just watch it later or don't watch it. I just need all of you guys' attention. Okay? So go to that table and you can see all the gas evolution reactions. And don't confuse that with combustion reactions. Because in combustion reactions, you can also see H2O gas plus CO2 gas, but that is not a gas evolution reaction because it's not in that table. Are we clear? What is an evidence of a chemical reaction? Can anyone tell me some of the evidences of chemical reactions? Yes? Yes?
Formation of bubbles.
Yes?
Gases emitted.
What's that?
Gas.
Yes, seeing a gas. And then the bubbles, be careful because they can also be physical change. If I boil water, I see bubbles, but this is physical change. So you should see new materials. Yes?
Formation of solid.
Exactly, like precipitation reactions, right? What else? Exactly, temperature change, like, and also, light emission or like heat emission or heat absorption, right? All of them are evidences of chemical.
So can change in enthalpy be evidence of chemical reaction?
Yes, exactly, because that is producing or absorbing heat. So physical versus chemical change. And then if, I asked you this in one of the homework problems, and then if you go to the book, you see more examples. And I asked from those. Some of them, if you open a can of soda, you see bubbles, right? Or you hear sound, right? So is that a chemical or physical reaction? Physical. Or like if we subliming a material, or like if we have evaporation, or like condensation, are they physical or chemical? Yes. Okay. So how do we balance the chemical equation? And what is balancing chemical equations? Why do we balance a chemical reaction? What law do we want to conserve? Exactly. So matter is not being generated or destroyed. We have if you have 2 moles of oxygen on the left, or let me paraphrase, if you have 2 oxygen atoms on the left side of the equation, you should have 2 oxygen atoms on the right side. And do you know when we balance a chemical equation, which element we do last? Exactly. If you see H2 by itself, or O2, or Fe, or Cu, or C by themselves, you just balance it last. So, can you tell me, I don't know the person next to you? So can you tell me, how do we write a complete ionic equation? So imagine I gave you an equation like NaCl plus Ki, right, gives the product. How do you write complete ionic equation? Do you know? Does anyone know? Exactly. So if you have NaCl plus Ki. So you say that, okay, this one is Na plus Cl minus K plus I minus. You write the ions, cations and anions, right? And then you see when you do that for the whole reaction, it's like the first homework problem that I told you, told you to email me the solution. You see some ions that they don't participate, so those are spectator ions. And you don't do this for liquid, solid, and gas. You only do that for aqueous solutions. And then when you omit spectator ions, you can write net ionic equation. Okay, so what is a redox reaction? Or oxidation reduction reactions? What is the definition? Exactly, but what is oxidation? Or how do we know what is the main characteristic of oxidation reactions? Yes, transfer of electrons, right? And then you should be able to identify them too. And then you had 3 main rules, so how to identify them? So I just encourage you to go to your book and then see, and then know the definition. I asked you true or false. Oxidation reduction reactions are reactions that they produce oxygen. True or false? False. It can be, but it's not the definition. We should have transfer of electrons. So solubility table. I asked you to remember solubility table, and I'm going back to this because I have the table to show you. But knowing that. And then greenhouse effect. What is it? What is the main greenhouse gas? Exactly. And then the definition I'm going to ask you. What is it true or false? And I give you a definition. It can be true or false. So know that. And then stoichiometry. What is a stoichiometry? The relationship between the reactants and products, the quantitative relationship that makes you, solve the problems, right? It's kind of like your cooking recipe. So now, and as I said, the definition and how to balance chemical reactions. So is the following statement true or false? In chemical equation, we can change subscripts of elements. Exactly, because we don't change the elements, we just change the coefficients. Okay, now let me go to the solubility table. So I asked you to remember this table. To make your life easier for exam 4, as long as you know these ions here, you can answer your question in test. So compounds containing the following ions are mostly soluble, and these ones have no exceptions. So if you see a compound that has lithium, sodium, potassium, and this is group 1A, right? And then ammonium, nitrate, acetate. If you see a compound that has these ions, they are for sure soluble and they would be aqueous, right? So if I say like NaOH, KCl, LiBr, NH4, NO3, and so on and so forth. As long as they have like these, if you just remember lithium, sodium, potassium, ammonium, nitrate, acetate. So can you, I'm just referring to you two that you're talking till the rest of the class. So can you name these ions that I just mentioned? Yes.
Sorry, the ones you have written.
Yes, you just say.
Sodium hydroxide, calcium chloride, lithium.
Yes, it's just these ions here, these ones.
Lithium,
Uh-huh.
sodium, potassium,
Uh-huh.
ammonia,
Ammonium, yes. Nitrate, yes.
and I'm not sure this.
Acetate. So as long as you see these, and as I said, if you just pay attention now to me 100%, you can get an A in your test, and that is my main goal. So these ones, these, any compound that has these, they are soluble in water, so you see aqueous. Any questions so far about anything that I said? Okay, I already went through stoichiometry, so I go to the next slide. Okay, electromagnetic radiation. And we talked about this spectrum, right? But can anyone tell me the name of the electromagnetic radiation from the highest energy to lowest energy? What is the highest energy? Gamma, yes. What is the next one? Yes, what is the next one? UV, ultraviolet, yes. What is the next one? What is the next one? Infrared, right? And what was after infrared? And then? And remember, the most dangerous one has the most energy, gamma rays. And then X-rays, and remember the example that I said, that gamma rays are like the most dangerous one, just remember. X-rays, that's why the technician goes out of the room, because they don't want to be exposed to constant radiation. And then ultraviolet, you put sunscreen, because if you don't, and then you go to the beach every day, you get skin cancer, God forbid. But that is dangerous too, but not as much as the other two. And then ultraviolet, right after ultraviolet, you had violet, which is part of visible light. Did we mention visible light? Yeah. Okay, so visible light, sometimes I just try to go through the materials. I forget what I said. So we have visible light, and then the last light on visible light is red, and then you have infrared. So in that way you can remember that, right? And then you have microwave, and then you have radio waves. And then remember, gamma rays has the highest energy, so it's the most dangerous one. And energy and frequency, they have the same trend. The highest energy also has the highest frequency, but they are reversely connected with wavelength. So gamma ray that has highest energy has the smallest wavelength or shortest wavelength, And radio waves are kind of, as I said, it's kind of like has like long wavelengths, but the lowest, smallest energy. And I asked you from what I just said in the exam. So if you just learn this, you'll do that problems, 1 or 2. Any question about that? Good? Okay, so knowing that, wavelength and frequency, they have the same trend, but, frequency and energy, they have the same trend, and they are like inversely related to wavelength. The highest wavelength has lowest energy. Is that clear? Okay. What is Bohr model? Can anyone tell me what is Bohr model? I'm just gonna bring my book too. Meanwhile, yes, just say.
Electrons are placed in orbital near around nucleus.
So this is the thing that I tricked you in the exam. So you have like, in Bohr model, we don't talk about orbitals. We just have orbits. And it's kind of like the planetary description, that you have like planets, orbiting around the sun. It's the same thing. Remember, in Bohr model, you don't have orbital. So if I tell you which one of the following is the definition of Bohr model, and you see the word of orbital, it's not correct, because that is quantum mechanical model. In Bohr model, you have like a planetary description of electrons and nucleus. So you have your nucleus and electrons orbit around that. And you have like different orbits. And then you say like n equals 1, n equals 2, n equals 3, and so on and so forth. So in Bohr model, we only have n, principal quantum number, orbits. We don't have orbitals. Is that clear? So what was orbital, now that we are on the subject? So orbital, anyone? Yes, the probability of where electrons can be around the nucleus, right? And you all know what is probability, right? Yeah. Okay. So that is, remember, in Bohr model, you don't have orbitals, you have orbits. But in quantum mechanical model, you have orbitals to describe the probability of where electrons are. Okay, and now SPDF orbitals. Can anyone tell me what was the shape of S orbitals? What was P orbital? Exactly, and that's what I'm going to ask you in the exam. D and F, you can go to the book or like the slide that I posted, see the shapes, but just know how many electrons can be in each of them and how many. Can anyone tell me? So if I have these 1, 2, 3, 4, 5. Which one of these are S orbitals? Which one of them are P? Which one D? So here you can have maximum 2 electrons. How many here? How many here? Right, because 1, 2, 3, and then I guess this is bad teaching. 1, 2, 3, 4, 5, and you remember that based on Hahn's rule, you fill them singly first and then pair them up, right? And same thing here. So electron configuration, including valence and core electrons and orbitals. So what was valence electrons? Exactly. So in the outermost layer, when you write the electronic configuration, you say 1s, 1s2, 2s2, 2p6, 3s2. Just for the configuration that I said, how many valence electrons do I have? So you go to the outermost layer, it means like the outermost n. So now I said 3s2. N equals 3 is the outermost layer. And number of electrons in that shell would be my valence electrons. So in this example, 3s2, 2 electrons are like my valence electrons. Is that clear? So for instance, if I have 1s2, 2s2, 2p6, how many valence electrons do I have? Remember, you go to the outermost layer or outermost shell. So here, n, and that is your n, remember. You can say n equals 2 is outermost shell. So in n equals 2, I have, total, this is 2s2, 1, 2, 3, 4, 5, 6. So in general, 2 plus 6, I have 8 electrons in n equal 2, right? So that is my valence electrons. Is that clear? Yes.
Is the n always determined by the coefficient?
Yes. So the outermost layer is the largest number of n's that you see. If you see like 4p6, is it the largest number that you see? That is your outermost shell, and that n equals 4 determines your valence electrons. But you should count that for all of the orbitals. So here you have 2 here, 2 here, and then you have s2, p6, and these are number of electrons. Do you remember that when we were writing those? So if I write like 1s2, 2s2, 2p6, you see the largest number 2, right? Any question about that? And then you go to all the orbitals that have the principal quantum number of 2, meaning like these guys here. And then you add these electrons. So you say 2 plus 6 equals 8 valence electrons. Is that clear? Any question about this? So if you have any questions about anything that I'm saying, just ask that, because I don't want you lose points because I couldn't teach something well. Okay? And now, anything that is left is your core electrons. So in this case, you have 2 core electrons. And if I ask you how many orbitals I have, you count these squares here. So here I have like 1s2, 2, right? So this is corresponding to my core electrons. So you count 1, 2, 3, 4, 5. So you have 5 orbitals overall. So just remember, as I said, when you see an electron configuration, you see the largest number that you have. Like here, you see the largest number is 2. You don't see anything more. And then you count all the electrons corresponding to 2 numbers. So you see like 2s2, 2p6. Those 2 and 6, the numbers that we write above are number of electrons. You have 8 valence electrons. You have 2 core electrons. Anything that is remaining. Good? Any questions? Oh, sorry.
How does that work when you get to 4S and 3D?
So again, you just look at the really good question. So you just look at the largest number. So 4D, that is 3s4 you asked, right? 4 is your largest number. So anything that has 4, those are your valence electrons. Does that make sense? So n equals 4, you count the numbers for those. Any more questions? Okay. Now, Pauli exclusion principle. Can anyone tell me what was Pauli exclusion principle? Exactly. Just what your friend said. So when you want to feel like orbitals, I'm just writing here, you can maximum have 2 with opposing spins. Clear? And what was Hund's rule? I just mentioned that briefly previously too. Yes, so when you want to fill out orbitals similar with the same energy, you fill them singly first, then pair them up. Clear? Okay. So now, let me go, it said Hans rule. Okay, theoretical yield, I always do that, okay. So, theoretical yield and limiting reactant. What is theoretical yield? Yes?
The amount of yield your equation says that you will have.
Yes, so the maximum amount of product that you can have based on your limiting reactant. And what is your limiting reactant? Or how do you determine limiting reactant? Limiting reactant is the reactant that limits your chemical reaction. It's kind of like the pancake example. Remember that I say like 2x plus 3 cups of flour gives 5 pancakes. And I have at home 2 eggs and like 100 cups of flour. I can only make pancakes based on 2 eggs. Although I have lots of flour, that doesn't mean anything. I cannot make pancakes with it because I don't have enough of one of the ingredients, right? So limiting reactant is the reactant that limits the chemical equation. And how do you find it? Can anyone know based on the quizzes that you did? How do you find limiting reactant?
Find the theoretical limit for compound.
Yes, you find the amount of product for each of the reactants depending on how much you have, and whichever gives you the smallest amount of product limits your reaction. So it's a limiting reactant. And I'm going to go, solve the problems for you quickly so you see what I mean, but know the definitions as well. What is enthalpy of reaction? Yes? Yes, the amount of heat absorbed or released in a chemical reaction that occurs in constant pressure, right? And I asked you, I'm just telling you, I asked you the definition of enthalpy and enthalpy of reaction. So go to your notes, to the book, whichever, to the lecture, and then, kind of like review enthalpy of reaction. And then periodic trends, atomic size, ionization energy, and metallic character. And I went through these really fast last time because I didn't have much time. So if you just remember, so these ones are these trends, and you saw that in the last homework assignments. I'm going to ask like 3 or 4 questions from these. So be prepared for that. So if you just look at your periodic table, can anyone tell me where do I see metals? Yes, so here, I just keep doing this. Okay, now I choose like the red. Okay, here you have alkaline earth metals. Here you have your transition metals. These are like inner transition metals, So here you see like most of the metals, right? And here you see most of the non-metals, and this one is actually non-metal too. Hydrogen is exception, but except that, in general. So if you remember this, and by now I hope that you know that, right? Your transition metal, you have transition metals, you have alkaline earth. So if I tell you that when I go from left to right in periodic table, metallic character increases, true or false? False. You see, and then if you just remember, and I give you the periodic table, but just remember, these guys, halogens, noble gases, they're not metal, right? And then, when we go from the above here, I cannot see it in my screen, so that's why it's kind of messed up. When you go from up to down, metallic character again increases. And you can remember that because here you have, and I have another image as well that shows that better, I guess. I can just demonstrate that as here. So here, you have like boron, silicon, germanium. Here you have your metalloids. Do you remember? So going from up to down is as if elements are transitioning from non-metal to becoming more metal. And then here you see metals. You see what I'm saying? What I'm going with this? Here, carbon is non-metal, and then you see metalloid, and then you see metals. So when you go, if I ask you, when I go in the periodic table from up to down, metallic character increases. True or false? True, right? And as I said, you can just remember these metalloids, that they are like between metals, non-metals. It's as if the elements are transitioning from being non-metal to metal. Is that clear? Any question about that? Because I just don't want you to just, memorize things without any rationale. Because if you just memorize a sentence without knowing what it means, you may forget it so quickly. But if you know exactly the trends in periodic table, things make more sense, right? Okay, the other thing was atomic size. Do you remember that I told you when we go from each layer, like n equals 1 to n equals 2 to 3, if I add one more n, number of n increases. So I will be having more shells. So having more shells means atomic size increases. And can anyone tell me what is the definition of atomic size?
Distance between the center of the nucleus and the outermost shell.
Exactly. So the distance between nucleus and the outermost shell is your atomic size. So if I have like n equals 3, the atoms would be larger, right? So is the following statement true or false? When I move up to down in periodic table, atomic size decreases. Is it clear for everyone why it is false? Any question about that? And then when going, I guess, I just show you this picture, not this one. Here. You see, when you go up to down, atomic size increases, and when you go left to right, you see atomic size decreases. And we said because you have like more electrons, the number of electrons increases, and there are like more attraction between valence electrons in outermost shell, and the atom. So the atom shrinks in a sense. It becomes smaller. Does that make sense? The number of n is the same, but more electrons. If we have less electrons, they have more freedom. So the atomic size increases if you have like less electrons. Any question about that? And last, we have ionization energy, which it was just a table that I showed here. So can anyone tell me what is the definition of ionization energy?
The amount of energy required to remove an electron from the outermost shell.
Exactly. So if again, the ionization energy is the amount of energy required to remove an electron from an atom. So do you think metals would be having higher ionization energy or lower? Right? Is that clear? Because in metals, you will be having cations, right? So if metals want to lose electrons, so there are like small amount of energy required to remove electrons. But halogens, for instance, you have Cl minus, Br minus, right? They want to gain electrons. So if you want to remove an electron from them, it's really difficult. So we should give that more and more energy because they want to not only lose the electrons, they want to attract. So they have higher ionization energy. Is that clear? Any question about that? So based on that rationale, when you move in periodic table from left to right, from metals to non-metals, ionization energy increases or decreases? What about up to down in a column? We remember that first we have more non-metallic character. Like if you look at like the groups 3, 4, 5A, you have more non-metallic character, and then you're transitioning to metals. So up to down, ionization energy increases or decreases? Because we're having more metallic character. Are these things clear? If everything that I just talked about is clear to you guys, you all are going to get 100. So now I have 10 minutes, and as I said, don't worry about the quiz. I'm just going to post the solutions today. So don't worry about that. But I'm just going to go through it briefly. I just wanted to make sure that I review these materials to you, because you should know these before going to the exam. And I have 10 more minutes, so don't rush me, guys. Okay, so insert. Go. Okay. So which of the following does not involve a chemical reaction? Which one? Okay, great. Is the following statement true or false? We are allowed to change coefficients and subscripts by balancing chemical equation. And read the whole statement in the exam. Now I'm just rushing to finish, so I just go briefly. Balance the following chemical equation by substituting A, B, C, D with suitable numbers. So which one of these? Okay, so yeah, that's the product of the apple, what it does. Anyway, so we have PbC2H3O22 Na2SO4 aqueous. I guess I just skip aqueous too. Gives PbSO4 plus NaC2H3O2. Remember, if you have polyatomic ions, and I just want to rush through, I just tend to yell. I don't mean to be mean. I guess you see that I just want to record and then just rushing through. Anyway, so polyatomic ions, when you want to balance them, don't separate them. Don't make your life difficult, right? So here, C2H3O2, C2H3O2, don't separate them, just balance them as themselves. And then the same thing with SO4. Don't separate them, don't make your life difficult. So if you don't do that, how many sodium should I put on right side? Well, what should be the coefficient? 2, right? And then you'll be having 2 Na here, 2 Na here. What about, so you have 1 Pb, you have 2 C2H3, 2 here, 1 here, 1 here. So the coefficients are 1, 1, 1, 2. 1, 1, 1. Is that clear? So don't separate polyatomic ions. Don't make your life difficult. Any question about that? Which of the following is not a gas evolution reaction? Is that clear? Why? Exactly. And if you go to the table that I just said, right, you see the reactions. Anything that is not that is this one. Okay. Which of the following compounds is insoluble in water? Which one? So this one is, so nitrate was among the ones that was always soluble, right? And then here, what about CAS? Okay, what about this one? B, what about this one? Soluble or insoluble? Okay, so this is the, but as I said, for your exam, these ones, you have your book, you can just look at it. For your exam on Friday, as long as you know which ions are always soluble. Can anyone tell me? Yes, lithium, sodium, potassium, ammonium, nitrate, acetate. Those are always soluble. Which of the following reactions is correct? So, see? So, again, you see Na, and you remember that to determine precipitation reactions, you write the ions, so you switch the anion, you switch the cations here. So here you have Ki NaCl, right? You have K plus I minus Na plus Cl minus. You switch the cations. and you write Na plus with I minus, K plus Cl minus. So you'll be having potentially NaI and KCl, but we don't know yet. But if you do, you'll be having this. You go to your solubility table. If they are soluble and aqueous, both of them, you won't be seeing any reactions. If you see a solid, you will be having precipitation reaction, right? Because in precipitation reaction, you mix two aqueous solutions and then you see a solid, right? So here, Na, K, they always are soluble, right? So they don't give precipitation reaction. And then the same thing here for like, it's kind of arrow, it becomes like this thing. So Na, nitrate, these are like always soluble. And then here, K, Na, they are always soluble, right? So these should be your answer. Is that clear? So when you want to see whether or not you have a precipitation reaction, you write your anions and cations for both of the compounds, okay? What I mean is that, for instance, for this one, Ki is K plus I minus, right? And from chapter 5, you know how to write this, right? You remember that your group 1 had the metals have charge of +1, these ones have +2, halogens have -1, oxygen, sulfur -2, nitrogen -3, right? So, and then for Pb, NO3 you have Pb2 plus NO3 minus, so, right? Is that clear? And what you do, you switch the cations. Is as if, it's double displacement reactions. And then you write a compound with Pb2 plus I minus and K plus NO3 minus. So this one would be Pb, or you don't even have to write it right now. You go to your solubility table, see what if these two ions combine. Is it soluble or insoluble? If you see they are. And then the same for like K plus NO3 minus is easy because both of these are soluble. So this one is soluble, aqueous. And then you see for this one, they are insoluble. So you see solid. So you have a precipitation reaction. Is that clear now? Okay, just email me if this is not clear or anything else that I'm saying. Which of the following statement is not correct? Compounds contain. So this is just like your solubility table. Go through the next question. So, which of these are not redox reactions? Why? What's that? So here you have like an acid plus base gives water plus an ionic compound or salt, right? For the other ones, you have like, transfer of electrons in all of them. Here you see just a metal by itself. Here you see like the transfer of electrons, or like again metal by itself. Here you see oxygen. So all of the other ones are acid-base reactions. Is that clear? So again, I went through what I did to make sure you do well on the test, but I'm going to post the solutions. But please, email me if you have any question, and I try to be available. I scheduled office hours for tomorrow. I posted in the website. I try to be at my office for most of the day. So if you have questions about any of these quiz problems, just come to me and talk to me. I just go through with them and review them with you, and hopefully you all can get an A in exam. That is my intention. Yes.
Like
Just have all of it. Yeah.
So I
that's fine. You have your name on it? Oh, okay, that's fine. Don't worry about it. Yeah.
Wait, so we don't need to put our solutions on the website too?
What's that?
We don't need to post our solutions on the website. Like with the quiz.
So I asked you guys to give me the Scantron here and post the solutions in BBLearn.
Okay.
Yeah.
That work.
Yes, exactly. I mean, not for the problems that are just like you know the answer or conceptual. I don't need work. You know what I mean? But for the solution, for things that need to write something, I just want.
I just put the Scantron on there, so is it okay if I?
Can you just email me that too, so I make
Yeah.
sure that I have
Okay.
it? Yes.
So I accidentally turned in the wrong picture of, I turned in a picture of the Scantron, but I turned it in here too. On the back side, there's my work, so if you want a picture of the work, just like the mail to you.
So can I see that in the? So.
No, so I only submitted the picture.
Okay, so
of the
just like
Scantron.
email me.
So can I just email you?
Okay.
Yeah, but
Yeah. Just do it ASAP because I'm just gonna post the solutions. Momentarily, of course. Okay, do you have them stapled those? Or like, do you have your name on it? Yeah. That's fine. Cool.
On the website.
Yes, so chapter 9, I still should finish it, but I finished for the first part of the chapter, so you guys have time to study that. I'm going to, so chapter 7, 8, and half of chapter 9 is on the website, but I'm going to post the rest tonight.
Thank you.
Of course.
Well, if we sign up for a makeup exam, where would we go?
So did you see the email that I sent right after the sign-ups? So I already, proctor all the makeup exams.
Mm-hmm.
So if you just email me and I work with you to take the makeup exams. But I really wanted everyone to study them because if you don't know those materials, it's really
Right.
hard to do the rest. But just email me.
Okay.
Nice. Of course, it seems like there is no class after here, so I guess I have the class on myself. What's up?
Just curious, I saw the email that you sent out that said that you can do all the extra credit before Friday.
Uh-huh.
So will you still count?
Yes, of course. Yeah, just make sure to submit them. And I emphasize to submitting them because I asked like most of the questions in the test from the homework problems. So if you know how to do them well and just upload them, you'll find.
Thank you.
Of course.
We just about the quiz. So I uploaded my work and I accidentally missed like one page on there for my quiz. I'm not gonna get marked down.
Just email me that page that you missed.
Just a picture of it.
Yes.
Okay.
Just email me that.
Sweet.
Yeah.
Sounds good.
Of course.
Thank you.
So you want a digital copy of our work, or do you want us to turn it in as well?
If you just have it, I mean, I add.
Because this is where I did my work.
Can you just take a picture of it, upload it in BBLearn?
Okay.
Yeah. I mean, you can hand it here too, but it's just like more organized in BBLearn.
Okay.
Thank you.
So I didn't realize that there was a quiz for I was stopped on how to do a test yesterday and how to prepare for the one that the remake I'm doing today.
Okay.
So can I just post the answers online as soon as I?
So study the answers that they post because those are important for your exam, but I'm going to just email me. I'll write a makeup quiz for you. And it would be like next week, yeah. I mean, I have some students that they asked me for extensions and then they said they weren't doing well, so I'm going to write a makeup quiz for.
Makeup quiz for 4.
So yeah.
Okay. So I just wait until next week.
Yes, I try to post it like this week or like but just email me to remind me because I know who missed that. So
Okay, thank you.
of course. What's
I'm
up,
sorry.
guys?
I just wanted to clarify. So McKenna, she already emailed you about wanting to take the retake exam.
Yes.
And I emailed too, and he said that I could sign up this week for it. And I did sign up, but I just wasn't sure where we were supposed to go for it.
Is it like your
Oh,
office
so you
hours or
already
something?
emailed me?
Yeah. And we
Okay.
already signed up and
I
stuff.
think it would be, so just come to my office, so it's like tomorrow at 4 and the day after, like tomorrow or today at 4.
Mm-hmm.
So I think it would be 2:20, but first come to my office and then we walk to 2:20. I think it should be fine, but I should make sure that the room is empty.
Okay. And then
So did I
I don't know, cause I emailed you about retaking the
okay,
exam
what
like
did I say?
before break, And he said to sign up, and so I just signed up for after break because I did want to. I've been studying over break for it.
So didn't I say to just
but-
show up to one of the times that I listed in the?
Yeah.
Okay, so that is my confusion because I said that in the times that I posted, I didn't post any makeup time for today and tomorrow because I wanted you guys to focus on exam 4.
Right.
But anyway, if you want, you can take it today at 4 or
Okay.
tomorrow at 4. But as I said, I just wanted to be considerate for you guys so you
Yeah.
have time for exam 4.
for sure. Yeah. And then can you remind me where your office is?
Yes, Renfrew 001.
Perfect. Thank you. Okay. So just show up there around 4
Yes.
tomorrow.
Yeah.
Okay. Perfect. Thank you so much.
Of course, of
Have a
course.
good rest of your day.
You too, just watch for the quiz solutions and then just email me if you have any questions about it.
Okay. Well, then, thank you.
Of course. Okay, everyone. I just wrote down the solutions for your quiz 4, but I also thought to solve them, at least the problems that are quantitative, and most of you asked me about those, so there won't be any confusion about those problems. So the ones that are like, theoretical or like conceptual, which of the following does not involve a chemical reaction? Is the following statement true or false? For those ones, I think just looking at the solution that I wrote should be good. And then some of them I just explained during the class, so I just don't want to make this video lengthy, if that makes sense. So I just go through the examples and problems that I didn't go through in the class and also are like more quantitative that most of you have or some of you might have issues. So first, let's start with number 12. What is the coefficient of water in the balanced chemical equation for combustion of heptane? And I told you this is C7H16. Remember, combustion reaction, you always react that with O2. And I asked that in the exam, as I told you, which of the following is not a combustion reaction? So if you don't see oxygen on the left side, if you don't see that, you won't be having combustion reaction. Let me just delete this line. Just kind of like cluttering here. This is too thin. Okay. Anyway, so you react that with oxygen, and if you have carbon here and hydrogen, elemental carbon and hydrogen, here you'll be having CO2 plus H2O. In most combustion reactions, you have CO2 plus H2O, not all of them. So remember, these oxygen, if you have elemental oxygen or like hydrogen, you do balance that the last. So here you have 7 carbon. So I put 7 here. And then you see if you don't have subscript, it means it's 1. 7 multiplied by 1 is 7. So 7 here, 7 here. And then we go balance hydrogen. So here we have 16. We have 2 here. 16 divided by 2 would be 8. So I put 8 here. 16 here, 16 here. And now I count oxygen. 7 multiplied by 2 plus 8 multiplied by 1. Right? So you multiply subscript with coefficient. Equals 14 plus 14 plus 8, 22. So here you have 2. 22 divided by 2 would be 11. So that's that. So here the coefficient here is 1 for C7H16. Is 11 for O2 is 7 for CO2, 8 for H2O. The problem asked for coefficient of water, so the answer would be A, 8. Okay, the next one. Number 13. Ammonia NH3 can be synthesized by this reaction. And then the equation is not balanced. NO plus H2 gives NH3 plus H2O. Let's first balance this. So we know that hydrogen, we do that last. One nitrogen. We have one oxygen here, one oxygen here. So you have 3 plus 2 equals 5 hydrogen. How would you make this one? So you have one number, multiply by 2 because you have 2 equals 5. So this number would be 5 divided by 2. And we just write it as such. But as we said, in balanced chemical equations or in chemical equations, we don't want to have decimals or ratio. So we multiply everything by 2. It would be like 2NO plus 5H2 gives 2NH3 plus 2H2O. I hope it's clear. Just email me if something doesn't make sense. So I go to the next page to finish number 13. So now the equation is like 2NO plus 5O2 gives 2NH3 plus 2H2O. I just don't write the gases, so save space. But you write the state of the reactants in parentheses. So it says, what maximum amount of ammonia in grams can be synthesized from 10 grams of NO and 20 grams of H2. So when you'll be asked from maximum amount of a product or ammonia, that means theoretical yield. And for theoretical yield, and yield is your, amount of your product. So don't get confused by the name. So here what you do is that now you calculate the amount of product for each of these, and whichever gives you the least amount of product, that reactant is theoretical reactant, and that number that you calculate would be your theoretical yield. And remember the pancake example that I gave several times in the class and also in the book, that although, if 2 eggs plus 3 cups of flour gives 5 pancakes, even if you have only 1 egg, and even if you have all the flour in the world, you cannot make, pancakes corresponding to all that flour because you only have 1 egg. You will be having less than 5 pancakes. So if that makes sense, if you have 2 eggs plus 3 cups of flour gives 5 pancakes, imagine you have 1 egg and then you have 1,000 cups of flour. It's kind of intuitive if you think about it. If you want to make pancakes, how many you can make? You say, how many pancakes equals 1 egg? Multiply by egg, pancakes. 2 eggs give me 5 pancakes. And then, so 1 egg gives me 2.5 pancakes. Although you have lots of flour, that doesn't matter because you don't have enough of this. That is limiting ingredient. So here we do the same thing and find the theoretical yield and limiting reactant. Okay, let's do this. So we say how many grams of NH3 equals 10 gram of NO. Multiply by gram of NO. Right? Do you remember how to write conversion factors? So something that is really important here is that the balanced chemical equation gives you the relationships between moles. And remember, it's kind of like when you were writing, like, do you remember the chemical formula was giving you information about like moles in your compound? I would say that how many moles of hydrogen I have in 1 mole of MgOH2, and then you would shout that we have like 2 moles of hydrogen, 2 moles of oxygen, 1 mole of Mg. So it's kind of similar thing here, that here for 2 moles of NH3, you have 2 moles of NO, 5 moles of HO, if that makes sense. So here you write mole of NO, and then convert mole of NO to mole of NH3, because you have NH3 here, and then convert mole of NH3 to grams of NH3. And then do you remember at the back of your book, you have like the atomic masses. So N plus O equals 14.01 plus 16. Do you remember? You have nitrogen here, 14.01, oxygen 16, right? So that number would be 30.01, and then you do the same thing for NH3, would be N multiplied by 1 plus H multiplied by 3, right? And then this number is like 14.01, this is like 1.01, and this number right here would be, for NH3, 17.04. This is 3.03, right? So these are gram per moles. Do you remember we said in chapter 2 that numbers by themselves, they don't mean anything. You should have always units. So here you say 1 mole of NO, it has 30.01 grams of NO in it. And then for this conversion, you look at the balanced chemical equation. 2 moles of NO, here 2 moles of NO. 1 mole of NH3, 17.04 grams. And then when you do the math, you find out this number would be 5.68 gram of NH3. And then you do the same thing for how many gram of NH3 equals 20 gram of H2. Again, gram to mole by molar mass, mole to mole by balanced chemical equation, and then mole to gram by molar mass. And then when you substitute these numbers, it would be 201. So I already wrote these down and uploaded those in the website, so you should be good. 485 gram of NH3. So you see that this number is considerably smaller than this number. So this is your theoretical yield. I guess this is not a good idea to write with this one, just highlight. And NO is your limiting reactant. And this amount, theoretical yield, is the maximum amount of product that you can have. Remember the pancake example. Even if you have all the flours in the world, if you just only have 1 egg, you can make just 2.5 pancakes. Doesn't matter, and this is same thing here. So that was 13. Now let's look at 14. So if you learn one question, the rest would be the same. It's kind of like just similar, it's just like for your practice. First of all, balancing this equation. HNO3. So let's start with nitrogen. So here, because you have like oxygen in 2 elements, we first do, nitrogen. So we have 2 here, we put 2 here. Now we have 2 nitrogen. We have 2 hydrogen here, we have 2 hydrogen here. What about oxygen? You have 3 here and then 3 here. So that was a is it? What did I do wrong? Okay, we have like 2 nitrogen here, 2 nitrogen here. Nitrogen is good. Hydrogen, I have 2 here, 2 here. Oh, you see, I was just like making a mistake. I didn't consider this, right? So you have 2 multiplied by 3 equals 6. So don't do the mistake that I did, try to write neat, not like me, cluttery and messy. Just try to write neat so you don't make mistakes. So you have 6 oxygen here, and then you have 2 plus 1 equals 3 oxygen here. Remember, this one is by itself, so balance this one last. So you have 6 oxygen here, and then you have 1 oxygen here, right? We don't want to change anything else, just change this one. So you should have 5 oxygen here overall. So, and you want to put a coefficient here. So you put a coefficient here and multiply by that by 2. You want that to be 5. You know what I mean? So this coefficient would be 5 over 2. So you'll be having N2 plus 5 over 2 O2 plus H2O gives 2 HNO3. Remember, we don't like ratios. So multiply this by 2. So you have like whole number. And then you'll find 2, if I can just write, 2N2 plus 5 O2 plus 2 H2O gives 4 HNO3. For some reason right now I'm rushing to Alva. I'm not in the class. I guess I just want the video to be short so you'll watch it. Because if the video is like, I think 20 minutes, it's most likely that you watch it. But I guess if you're watching so far, probably you'll watch till the rest, I guess. Maybe. Maybe not. Okay. I was just looking for what I wrote in the answering sheet. 2N2 plus 5O2 plus 2H2O gives 4HNO3. And now you have 28 gram of N2, 150 gram of O2, 36 gram of H2O. You want to find limiting reactant. It's the same procedure, it's just like more work. You say how many grams of HNO3 equals 28 gram of N2. And then how many gram of HNO3 equals 150 gram of N2. And then how many grams of HNO3 equals 36 gram of H2O. And this is O2. Right? And then again, with molar mass, you convert gram to mole, mole to mole by balanced chemical equation. Again, mole to gram by molar mass. For some reason, when I hold this pen, it's just kind of like uncomfortable on my hand. Anyway, so you remember, so I don't write this again, so HNO3, you say, for molar mass, you say 1 multiplied by H plus 1 multiplied by N plus 3 multiplied by O, remember? And then you substitute this number. This is 14.01. This is 1.01. Remember? So when you do that, you have these numbers here. And then here, the balanced chemical reactions, 4 moles of HNO3 corresponds to 2 moles of N2. And then this number is 63.02. And then you do the same thing here. Gram to mole, mole to mole, and then mole to gram. And then here, 4 moles of HNO3 corresponds to 5 moles of O2. And then 1 mole of O2 has 32 grams. You write O2 equals 16.2. 16 multiplied by 2. 32, remember? And then here you do the same thing. Gram of H2O to moles of H2O, moles of H2O to moles of HNO3, and then moles of HNO3 to grams of HNO3. And then these are 3 distorted 3s. Anyway, so you see like 4 moles of HNO3, you have like 2 moles of H2O here. And then 1 mole of H2O is like 18.02. And again, remember H2O equals to 2 multiplied by H plus 1 multiplied by O. This is 16.00, 1.01. right? And then when you do all these calculations, the first number would be 125.95 gram of HNO3. The second number would be like 236.33 gram of HNO3, and the last number would be 251.80 gram of HNO3. And you see that this number is considerably lower than the other ones. So this is your theoretical yield, and N2 is your limiting reactant. So the answer is A, N2. Right? Okay. So next question. 15. Consider this unbalanced chemical equation. Again, we balance. So we have 2 Cu here. I put 2 here. And then I have 1 C, 1 O. This was an easy one. So it says when 20 gram of C are allowed to react with 200 gram of Cu2O, 160 gram of Cu are obtained. Determine percent yield. So this one is your actual yield. The problem is telling you see this much of the product. That is your actual yield. And now you find theoretical yield and then put it in the formula, find the percent yield. So as I said, if you learn one of the problems that I just previously mentioned, all is just like the same. It's just like for your practice. You say how many grams of Cu equals 200 gram of Cu2O. And then you can convert gram of Cu2O to moles of Cu2O and moles of Cu2O to moles of Cu. And you see that these are canceling. And then moles of Cu to grams of Cu. And then you go to the back of your book, you see that this number for Cu is like 36.55, for oxygen is like 16, and then for next one for carbon here, we want to use 12.01, right? So what you do, you say Cu2O equals like Cu multiplied by 2 plus oxygen multiplied by 1, and then this number is like 63.55. Oxygen is 16. When you do the math, you get 143.1 gram per mole, right? And you put this number here. And then balance chemical equation. For 2 moles of Cu, you have 1 mole of Cu2O. And then 1 mole of Cu has like 63.55. And then when you do the math, you get 211.66 gram of Cu. Oh, sorry. I wrote the wrong number. So when you do the math, you get 177.64 gram of Cu. And now you do the calculation, similar procedure for carbon. Or yeah, then you have like C. How many grams of Cu equals 20 gram of carbon multiplied by gram of carbon to moles of carbon to moles of Cu, and then moles of Cu to gram of Cu. So this one is easy. We just write this number. And then this number is, you go to the balance chemical equation, 2, 1, right? 2 Cu, 1 mole of carbon. And then 1 mole of C is 12.01. Then when you do the math, you get 211.66 gram of Cu. So you see, you compare these two numbers. Which one is the smaller? This one, right? So this is your theoretical yield. Theoretical yield. It's kind of like theoretical yield. And then you remember that percent yield equals actual yield divided by theoretical yield. Multiply by, I guess, give some space, 100%. So remember, actual yield is like when I make pancakes, what I actually get. You may bake some pancakes but burn them all, right? Or you won't get any, or something happens, or you cannot get pancakes, or you drop them on the floor, or the dog eats it, or whatever. But theoretical yield is the amount that you get based on the recipe that you have. So here, actual yield, the problem told us 160 grams of CU is obtained. And then theoretical yield, we just calculated 177.64. So this is gram of CU, this is gram of CU, this we cancel out, multiply by 100% would be 90%, which is your C. Okay. Now, let's go to number 16. I think number 16 is the question that was giving most of you headaches. Consider the generic reaction. So it means that it's kind of like, do you remember when you were writing like combination, single displacement, double displacement, you were saying A plus B gives C. It's kind of like as if you wrote compounds, you balance the equation, and then you now represent them by A, B, C. So it's just kind of like your work is much easier here. It seems like more complicated, but indeed it is much easier. So remember, enthalpy of reaction. First of all, know the definition I asked you in the exam. I gave you like which one of the following is the definition of enthalpy. I don't know how I can be more clear on that. Just learn the definition of enthalpy, specifically on all other definitions. But this one I asked you in the exam. So this one corresponds to the balanced chemical equation. So you can say that 3 moles of A gives me minus 200 kilojoule, or like 5 moles of B gives me minus 200 kilojoule, or like 2 moles of C gives me minus 200 kilojoule. And then we can write the reverse too, right? So it's important for you guys to remember that, like the example that I previously gave about like making pancakes, right? So this one corresponds to this equation, these coefficients. But, I was telling students this example. Imagine if I burn one piece of paper at my office. It's totally manageable. I can just like have a blanket or like fire extinguisher. I can just control that. Or if, I guess a better example is accidentally that happens, So if you consider this piece of paper as a fuel, the fire is much less. But if I have like thousands of books, or if I have a tree, or if I have a forest wildfire, you see that the amount of heat being released is much different, right? It's as if like, a tree is burning or a building is burning. It's kind of like what I'm trying to tell you is the amount of heat is different. So here you don't specifically have in this problem 3 moles of A and 5 moles of B. You have different amounts, so you should calculate energy being released for that specific amount. So let me do this. 3A plus 5B gives 2C, and then delta H of reaction equals minus 200 kilojoule. And you are being told that you have 5 moles of A and 6 moles of B initially. What is the amount of heat evolved once the reaction has occurred to the greatest extent possible? So in all reactions, you should find theoretical yield. Meaning that, even if this combustion, so this one, first of all, this is a exothermic reaction because heat is being released, right? So you know that for combustion reactions, for the example that I was giving of burning, you should have oxygen. If you don't have oxygen, you don't see combustion reaction. So even if I have all the fuel in the world and I don't have oxygen, none of them would burn, right? So if I have like lots of oxygen but no fuel, I won't see combustion reaction. I don't see any heat being released. So it's really important that which one of reactants you have and which one limits the reaction. So that's why we should first calculate limiting reactant. And I do say how many moles of C equals 5 moles of A. And I say how many moles of C equals 6 moles of B. And remember how you would relate moles of A to moles of C. Balanced chemical equation. 2 moles of C corresponds to 3 moles of A. And then here, moles of B, these two cancel out, right? Moles of C. 2 moles of C corresponds to 5 moles of B. So it would be 10 over 3, which is like 3.33 moles of C. This would be like 12 over 5, which is like 2.40 moles of C. Which one number is smaller? Yes, this one. So this would be your theoretical yield, and B would be your limiting reactant. And you use this one to calculate how much heat being released. You say how much kilojoule or how much heat equals 6 moles of B multiplied by, and I just told you how to relate moles of B to kilojoule. Balanced chemical equation. 5 moles of B release minus 200 kilojoule. And then when you do the math, you'll see this number, it would be like 6 over 5 is 1.2 multiplied by minus 200. This number would be minus 240 kilojoule. All right, you can also use your theoretical yield, but I advise you to use your limiting reactant in case you made some mistake here, your answer won't turn out wrong. Okay, so I guess I can just go through this real quick. Which of the following is a component of white light? Red. Remember, so infrared, ultraviolet, gamma rays, those are like electromagnetic radiations, but they are not specifically white light or like visible light. Write the electron configuration of bromine. So remember, when you want, as I told you in the class, and we had a like long discussion about this in the class, when you want to write electronic configuration, remember the order that orbitals are being filled. You have first 1s, then 2s, and remember we denote orbitals with a number and a letter. The letter determines the shape. The number determines which principal quantum number we have or which orbits we are in, or what is the n. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Just remember. And we said that when n is equal 1, you only will be having one type of orbital, just s. When n equals 2, you'll be having s and p. When n equals 3, you'll be having s, p, d. And then when n equals 4, you'll be having s, p, d, f. Remember? But I told you I'm just going to ask you till here. I won't ask you any further. So just remember, when you write 1, you know that you should be having s. But for n equals 2, you have s and p. So you write 2s, 2p. For n equals 3, you have SPD. So you should have 3s, 3p, and 3d. But remember that 4s has like lower energy. So first we feel that one compared to 3D. So, and remember that s orbitals, they could have like, maximum 2 electrons, and then p orbital. So like or like subshell of p subshell has like 3 orbitals, 1, 2, 3. And then you remember that d ones had like 1, 2, 3, 4, 5. And then they can have maximum 10 electrons. So we went through this in the class. Anyway, so here you have 2 electrons maximum, you have 6 electrons maximum, you have 10 electron maximum. So if you just remember this, and it's just like easy to write because I just told you how, you write like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. But depending on what element you have like different atomic numbers. So in this question, I asked you bromine, and the atomic number is 35. Don't confuse that with atomic mass. As I said, this one doesn't have decimal point, it's written above the elements. So here, 35, if you just remember this one as a general rule, just keep counting, so 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30. So you have like 30 so far. So if you have, instead of 6, 5, this would be your electronic configuration, which would be A. I hope this method kind of clarifies how to write electronic configuration. What atom? So number 19. What atom has the biggest size? Fluorine, chlorine, bromine, iodide. Remember, all of them are halogens, group 7A. When you go from up to down, atomic size increases because one shell is being added to each of these, right? And remember, the number of shell, if you're like in the period n equal 1, or like it means that you have like one orbit or like one shell. If you're in second period, your n equals 2. In third period, your n equals 3. And then do you remember that here, if n equals 1, you have like, here, like, or if you have like n equals 2 or like n equals 3, it doesn't draw. Okay. And then atomic size is the distance between the nucleus and the outermost layer. So when you go up, from up to down in a group or family in periodic table, atomic size increases. What is the orbital? So it's not orbits, it's not electrons around the nucleus in exact locations. No, it's not circular path around the protons. No, it's probability maps indicating where electron is likely to be found. Orbital is that. 21. What is the limiting reactant for the following chemical equation and initial quantities of reactants? If I just give you if I tell you that, this is, the recipe to make pancakes. 2 eggs plus 3 cups of flour gives like 5 pancakes. And I tell you now, tonight, when I go home, and if I want to make pancakes, how many pancakes I can make? How can you tell me? Maybe I don't have any of these. Maybe I don't eat any of these, What I'm saying is that you won't know what is in my fridge or like in the cabinet or shelf or in my kitchen in general, because how would you know? This is like just a recipe, right? So this is the same thing. If you just see a chemical equation by itself, you don't know what is limiting reactant, or you don't know what is initial quantities of reactants because you are not given those information. So for 21, the answer is D. Okay, we're near the end, and that should be quick. 22. Which electromagnetic radiation is most dangerous to human beings? Gamma rays, because they have the highest energy. And then X-rays are the most dangerous one afterwards. That's why the technician, when you go X-ray your leg or foot, or like if you have like broken bones or like other problems, and you go to the doctor, the technicians always go out, because if they stay with all the patients, they most probably get cancer. And then ultraviolet radiation, again, after gamma ray and X-rays, they are also dangerous, but not as much as those. And then go to the electromagnetic radiation that you draw in your homework, and also to the book to kind of like remember those and memorize those. But you remember that you should wear sunscreen when you go outside. So I guess one of the takeaway messages from this course can be to wear sunscreen, because if you just go to the beach all the time, or like if you're exposed to sunlight all the time without sunscreen, you may develop, you're like higher chances of getting skin cancer. So those are dangerous too. Okay, but radio waves are not dangerous. They have like the least amount of energy. We use radio waves all the time. I guess, it can be proven that all of these things are bad. But as of right now, based on our course and syllabus and all that, radio waves are not as dangerous as the other ones. Which wavelength of light has the highest energy? Highest energy means shortest wavelength. So you just look at the numbers, whichever smallest, it's the smallest, it's higher energy, 100 nanometer. After balancing the following equation, what is the sum of all the coefficients? Consider all the reactants and products. So this one I'm going to write down. So here is your reaction. Hi plus BaOH2 gives H2O plus BaI2. Okay. So first, let's start with Ba. 1, 1. And then hydrogen is being repeated. Let's take care of it the last. You have 2 oxygen. You should put 2 here. 2 oxygen. And now you have like 4 hydrogen here. You have 2 hydrogen here. And then 1 here. So if you put 2 here. And then I guess the better option was first balance I. I is 2 here, so you put 2 here, and then you have 2 hydrogen here, 2 hydrogen here, would be 4 hydrogen here. So you have 2 Hi plus 1 BaOH2 gives 2 H2O plus 1 BaI2. And then you count these numbers. Imagine if you don't write anything, that means it's 1. If it was 0, it meant that you didn't have any BaOH2, which that is not the case. 2 plus 1 plus 2 plus 1. What is it? Yes, 6. The answer is 6. And that is your C. Is the following statement true or false? The Pauli exclusion principle states that orbitals may hold more than 2 electrons with opposite spins. Wrong. False. No more than 2 electrons with opposite spins. And I asked you Pauli exclusion principle. I asked you what is the Bohr model in your exam. I asked you, from the precipitation table, which one of the following is not a precipitation reaction. I asked you which one of the following is not a combustion reaction. And I asked you a question that you had to know, the solubility table. Lithium, sodium, potassium, ammonium, nitrate, acetate. Any ionic compound that has these ions, they are soluble in water. So you won't be seeing precipitation reactions with those. And I guess I just end this recording so it would be shorter so you watch it. And I hope, as always, that you all do really well on your exam. I'll be available tomorrow. I'll try to be at my office most of the day. So don't hesitate to reach out to me, contact me. Even at this point, if you don't know anything about these chapters, just reach out to me. And I'll try my best to update you and then teach you everything in a day. I'll do my best. Thank you. Have a lovely night or day, depending on when you're watching this. Night for me.